Hey guys, Mr. Palin here for your MCAS question of the day. I hate to say it, but I just recorded a 13-minute, well, I should say I didn't record a 13-minute video because I forgot to hit record and did the longest video yet. But I realized that this was a blessing in disguise because I was getting too wordy. I was taking too much time. I'm going to break down this problem for you much better and much quicker this time around. Okay, let me bring it up right now. So for starters, this I think is the most difficult one we've done so far. It talks about geometry, it talks about the coordinate plane, and it talks about a lot of different things you can do to a shape that is drawn on the coordinate plane. So let's bust into it right now and see what we can do. The key that I want you to get from today is that this question is all about the vocabulary. You need to know the math vocabulary here in order to be able to do this problem. Okay, I'm going to share my camera with you right now. Let me bring that up. First thing I want to go over, the coordinate plane, really quickly here. Okay, what the heck am I doing? Okay, the coordinate plane. This is the coordinate plane. It's the graph paper. You draw a cross on the graph paper and you go like that. You don't need graph paper, but it makes it easier. It just means the x-axis, the y-axis, the origin, the different quadrants, you know all that stuff. You should know all that stuff, but that is what they mean by a coordinate plane. They mean a graph. So don't get thrown off when they say coordinate plane. That's what they're talking about. Okay, you all know how to do that because you've drawn lines, you've done things like that. That's cool. So we're on the coordinate plane and we're talking about here, but go back to the question, congruent figures or congruent, or however you want to say it, congruent figures. Congruent just means figures, a shape that is the same, okay? That is two shapes that are congruent could fit on top of each other, and one wouldn't be poking out on the side. If you cut them out of construction paper and put them on top of each other, they would be exact matches. That's what congruent means, okay? So big to remember. Okay, so out of these 5 choices, you need to pick 3 that would result in congruent, the same, if you did it on construction paper and cut them out, figures that could then sit on top of each other and fit into each other exactly. And then they have all these different words that have to do with this unit on transformations in geometry. Okay, so let's bang through some of the vocabulary. Okay, here we go. And transformation, just like it sounds, it just means change. We're doing some sort of change to the figure here. In this case, it's a square they're talking about. Transformation just means we're changing it somehow. And then there's 3 types of changes that they talk about. The first one is translation. That just means to take that shape and move it from one spot to another spot in the graph. I have already done that because, like I told you, I made the mistake and didn't click record. It would be like taking a square that was down here in the 4th quadrant, we call it, down just the bottom right corner, and then doing some math to it that moved it up. Could I still cut that shape out of construction paper, take it, and then put it over this, and would it be an exact fit? Absolutely. So they are congruent. So we know that's going to be one of our choices. Next word is rotation. Rotation, you know what rotation is. You could have never sat in a math class ever in your life, and you would have known what rotation is. Rotation just means to stay in one spot, but move around left and right, like the hands on a clock rotate around the middle of the clock. Okay, so here's my drawing of that. The square would, if you twisted it like a doorknob or whatever, would just move in a circle, kinda, it would move around, but still, if I rotated it and there was a second figure on top of that, I rotated it and then cut it out, it would still fit on top of that. We just rotated. We didn't, in long story short, we didn't change the size of it at all. Okay, so we know now we're going to pick A and B. But you could tell by this question, you could tell that the hard part was going to be the dilation part, because they write dilation 3 times. 1, 2, 3. They're trying to confuse you. That's what they try to do on these types of questions. Okay, so what is a dilation? I went real long-winded on it in the last video that I forgot to hit record on. Dilation is like with your eyes when you go to the eye doctor. If you have been to the eye doctor, you have probably had your eyes dilated. You have probably heard of dilated pupils. Our pupils, you probably can't see it on mine. Oh yeah, see my little tiny pupils? the black circle, when you get dilated, the pupil gets very big. It changes size, dilation. Think about things that you can relate to your life and have that help you answer these questions. If that's what you have to do, it's okay. Dilation, my pupils get bigger. Okay, so what does that mean? All right, I know that means that maybe it's going to be dealing with change in size, okay? But now we have scale factors. So you got to pick one. You know for sure it's A because all you have to do is move it. You know for sure it's B because all you have to do is rotate it. Now you got to pick one of these, okay? The first one, C, has a scale factor of 1. The second one, D, has a scale factor of 1.5. The third one, E, has a scale factor of -2. Okay, scale factors are like what you find on a map. Okay, when it says one inch is actually 1 mile, you can think of that's the scale, right? Okay, if we are talking about a scale that is a 1-to-1 exact match, it means that there is no change. If it's 1-to-1, there's no change, right? But if it's 1 to 1.5, oh, well, it's getting bigger as we go. Or if it's 1 to, and I don't want to get too into it, the negative aspect of it, because we're really dealing with absolute value here. But again, I don't want you to have to do any math here at all. I just want you to use your vocabulary skills. So when we have 1 to 2, it is going to go from 1 to 2. It's going to get bigger. But 1 to 1, a scale factor of 1, means it's going to stay the same. So out of all these options, a scale factor of 1 means that it's going to stay the same. So the answer is going to be A, B, and C. But the main point that I wanted to really bring home here is it's so important to use those skills that you're good at. If you are an English person, not a person from England, but if you like to go to English class, you know what I meant anyway. If you are an English person that's good with like words, but not so good when it comes to like analyzing drawings and graphing and numbers and things, well then make sure you're tapping into your strengths. Make sure that you are solid on the vocabulary. If you are very good at remembering vocabulary, you've learned those skills and you've mastered them through your English classes, why aren't you using them in your math class? Use those skills. Get the vocab down, because you could have got that question just on vocabulary alone. And really, it wasn't even too hard. The dilation part was hard. But if you remember that the dilation scale factor of 1 means it stays the same, then you're going to be okay. You could have forgotten everything else. You didn't even know, you don't have to know how to even do a translation or rotate. You don't even know how to do it. You just have to know what those words mean. And then remember that whole cutting it out of a piece of construction paper and will it fit? Because that means it's congruent. Okay? Kind of a tough one today. I hope I explained it in as simple a way as I could. And I hope you enjoyed it. And hopefully we'll be back tomorrow with a much easier question, maybe. Let's see. Who knows? I'll see you then. Have a great day.